Let's talk about our first coding assignment. There are two Colab notebooks that are associated with this assignment. This one has the skeleton code and this one has the solution code. You can access these links in the attached PDF. You will implement three functions. myFT computes the discrete Fourier transform in one dimension according to the formulas that we have discussed. myIFT returns the inverse Fourier transform in one dimension. And the third function, getFrequencySpectrum, returns an array of magnitudes and frequency given the output of myFT. There are plenty of directions for implementing each of these functions in the Colab notebook. I've also included test cells to test your implementation against the corresponding SciPy functions. There is a fourth function that I've provided, plot frequency spectrum, that just gets the output of your functions and plots the frequency spectrum. So let's just click on this link. First you implement the Fourier transform according to this formula. Remember, omega is this. Just a quick hint, in Python you can use 1j to represent the imaginary unit I. This is the skeleton code. Remember that there is a nested loop. The inner loop computes the summation over all of the signal samples, and the outer loop computes the coefficient, the Fourier coefficient at each index k to fill up the Fourier array. This is the test cell that will test that function. You will implement the inverse Fourier transform in a very similar way. Here's the formula. There's the test cell for that. The third function is getFrequencySpectrum, given the output of a Fourier transform as well as the sampling frequency. And again, these are the formulas that you will use for that. There's a test cell for that. And finally, I've provided a plotting function that will help plot the output of your cells, and hopefully you'll end up with a frequency spectrum that looks like this. Once you've been through this exercise and implemented your nested loops, you'll realize that the time complexity of Fourier transform and inverse Fourier transform computed in this way is O of n squared, where n is the length of the signal or the number of samples. There's a faster way of doing this, which all the various libraries, including SciPy, use. That's called fast Fourier transform and inverse fast Fourier transform. They use a divide and conquer strategy to yield a time complexity of n log n.